recording, then I will share. So, okay, let's continue. As I mentioned, we need to define the directions of the X, Y, and Z axis. So in that case, we can define it when we know where is joint the two axes, two joints. In this case, joint I plus 1 and joint I. And each of these joints are rotating about the Z axis. So we say that if this is joint I plus 1, it rotates about ZI. And this is joint I, it rotates about ZI minus 1 axis. So our problem here is to really identify in this particular frame where is the xi, yi, and the zi. So we know already that zi will be in this axis because that is where joint I plus 1 is rotating. Okay, so now we need to know where xi is. So for xi, we know that xi will be orthogonal to zi. So any axis, we can define any axis that is orthogonal to xi. But then, because we need that xi to be orthogonal to zi minus 1 as well, and so that is how we're going to fix the direction of the xi axis. So in this case here, as you can see, if this is, we just copy that. If this axis was zi and xi will be orthogonal to it, like that. So the same thing as in the slide, it will be orthogonal. So then you have zi here in this direction. So for example, if zi is that direction, and so as you can see, this is also orthogonal. This is also orthogonal to zi. So in that case, if there's, for example, it won't be orthogonal, we need to rotate these two, because this can rotate, no? This can rotate because this rotates, okay, the link I, in this case, link I can rotate. So we need to rotate in such a way to find how can this xi be orthogonal to that and orthogonal to this axis and orthogonal to the other axis. Okay, so in that case, it is orthogonal to here. So we can fix now the direction of xi when it is both orthogonal to this axis, zi, and orthogonal to this axis, zi minus 1. So now xi direction is fixed. So once xi direction is fixed, then yi completes the right-hand coordinate frame. So that's the point. So now let's go. Then we know now the direction of zi, xi, and yi, and then we're done already in terms of frame I. So once we're done with frame I, now we will be able to determine the DH parameters of that frame I. Okay. So what are the DH parameters of frame I? There are 4. Okay. There are 4 in this case: theta I, alpha I. This is finished already the video. Okay. There are 4 parameters: theta I, alpha I, di, and ai. Okay. So again, now based on this DH convention, we define what is theta I. So theta I is where the angle about zi minus 1 from xi minus 1 to xi. So where is xi minus 1? So let's say this is about zi minus 1. So where is zi? So this is zi. Okay? And where is xi minus 1? Xi minus 1, this is xi. Can you see my mouse? Can you see my mouse?
Yes.
Yes.
Okay, I'll make this one bigger. Okay. So this is zi minus 1, and this is xi minus 1. Okay. So, and then where is xi? Xi is this. So when you rotate, okay, rotate from xi minus 1 to xi. So that means rotate this one to that. Rotate. This is xi. This is parallel to this one. So this is zi minus 1. So you rotate towards xi. So this is the one. So this is actually theta. This is a different symbol. I mean different looks, but this is theta, theta I. So from xi, where we can translate here, xi towards xi, I mean xi minus 1 towards xi, around or about zi minus 1, this is your theta I. So that's theta I. Okay? So what about alpha I? Alpha I is about xi. So where is xi? This is xi. About xi, so we rotate about xi from zi minus 1 to zi. So where is zi minus 1? Zi minus 1 is in that direction. So this is zi minus, it's not very clear, but this is zi minus 1. I wish I can make an annotation. See if we can see this one now. Okay. This is, can you see this line now? Can you see it? No.
Yes.
Okay. I'll make it.
Yes.
You can see it. Okay.
Yes.
That is, okay, that is zi minus 1, which is parallel to, this is, okay. Okay. It doesn't look parallel, but that's parallel. Okay. So these two axes are zi minus 1. And so the other axis is zi. That is zi. So, and the other one, maybe we make a red one. The red one is xi. So when you rotate about xi from zi minus 1, okay, now at least it's showing. So from zi minus 1, it's not showing anything. Zi minus 1 to, in this case, that's zi minus 1, and another one is zi. Okay, so from zi minus 1 to zi, you rotate about xi. So that is your alpha I. Okay, so the direction we're going to determine later. So it's normally whether it's plus or minus will be determined on the right hand rule. So in that case here, from zi, if you look at that one, from zi to z, from zi minus 1 to zi. So it's a positive direction, it's positive alpha I. Okay. So now so these two are angles. Theta I and alpha I are angles. So if we look at the arrow now, maybe we can do the other arrow now. That was for alpha I. For theta I, let me draw the arrows. So about zi minus 1. So this is zi minus 1. Okay. That's zi minus 1. And then we will look at from xi minus 1 to xi. So where is xi minus 1? So this is xi minus 1. And to xi is, this is xi. Okay. And again, because this is parallel, so this is xi. This is xi minus 1. So this is x, this is xi minus 1, okay, which is also parallel. Because it's parallel, we can say that this is xi minus 1, okay, and this is xi, okay. So when you rotate from xi minus 1 to xi, about zi minus 1, because this is zi minus 1, about zi minus 1, rotating from xi minus 1 to xi, so that is theta I, okay? That's how we determine theta I. Now, let's go to di. Di is along. So along, that means it's a distance. Along zi minus 1, so where is zi minus 1? This is zi minus 1. We're going to step along zi from the origin of the I minus 1 frame. So this is the origin of the I minus 1 frame. Okay, so let's draw that. Okay, that's the origin. You see that? Okay, and then that's the origin of the I minus 1 frame to the intersection of Zi and Xi. So where is the intersection of Zi minus 1 and Xi? So this is Zi minus 1. Let me draw again. This is Zi minus 1. Zi minus 1. And where is Xi? So let's draw Xi in a different color. That's Xi. And then we draw the text. Okay. So from the origin, we say from the origin of I minus 1 frame, that's the origin of that frame, to the intersection of Zi and Xi minus 1. So this is the intersection of Zi and I minus, of Zi and Xi. So, intersection of Zi minus 1, okay, and Xi. That's that intersection. So that means that in that case, we draw this. So this is intersection of, this is the intersection of Zi minus 1 and Xi, and origin of the I minus 1 frame. So from here towards, from here to there. Okay. So from this origin, says from origin of I minus 1 frame to the intersection of Zi minus 1 and Xi. So in this case, this is the DI. So we say there, the DI is there. Okay, that's the distance. Okay, next, we need to know the distance along Xi. So along Xi, where is Xi? So again, this is Xi. This is Xi. Along Xi, from intersection of Zi minus 1 and Xi. So where is that intersection? Again, we say that this is the intersection of, that is the intersection of Zi minus 1 and Xi. Okay, and to the origin of the ith frame. So the origin of ith frame is this. The origin of the ith frame is this. So that means that we will move a distance from this intersection along Xi, where this is along Xi, to the origin of the ith frame. Okay, so it's a little bit difficult to see now because because of how the drawing is shown, but once we go through some examples, it will be much clearer. But for now, let's just say that you know, there are some things that we need to understand. That for, in this case, this is AI. So AI, it will be along the XI axis. So this is the XI axis. So that's along the XI axis. We move along the XI axis. That will move along the XI axis. And then that is for AI. And then for DI, it's along the ZI axis. So along this axis, that's the DI. Okay. And theta I is about the Z. So about ZI minus 1 axis, this is about, so that's turning. So that's theta I. And then the other one is about XI, where XI that's turning, about XI to determine alpha I. Okay. So again, in this case, the Z and the ZI minus 1 axis is you rotate for theta I, and the distance di, you move along to get di, and then for the xi axis, about xi, you get alpha I, and you move along xi, you get ai distance. Okay, so those are the things that we need to consider. Now let's go to the next slide. Need the mouse. Okay. Now, after we know that this convention, okay, then we can determine how the transformation matrix I minus 1A to I. So how you transform from frame I minus 1 to frame I, okay? To do that, you need to transform from the Z, move from the Z axis towards DI. So that means in this case here, okay, let's just do this. So do you see this? So you transform from the Z using the Z axis a distance of D. So from here, from the Z axis, from this origin, okay, because we are from origin I minus 1 to transform to I. Yeah. So we need to know what is for any relationship, for any angles of joints, we will be able to see how do we transform from frame I minus 1 to frame I. So we move along Z-axis a distance D. So this transformation, this is just a translational movement from this point to that point, yeah, along ZI by a distance of D. So as you can see, this rotation matrix is one identity. There's no rotation. Okay, so this is 1, 0, 0, 0, 1, 0, and 0, 0, 1. That's an identity matrix. There's no rotation. So let me, there's no rotation. And then you move along Z-axis, move along Z-axis DI. Okay, you only move along Z, and you don't move any on the X and the Y. Okay, so you move along Z. So that's the one. That's the first transformation. So the next transformation is you rotate about Z by theta. Okay, again, this is the Z. You rotate by theta I. Okay, so Z-axis from here, you rotate by theta I about Z-axis. So again, now in the rotation, position, there's nothing. Position, there's all 0, 0. And then rotation, you have rotation here about Z-axis. So because about Z-axis, we know that here will be 0 and 1 will be about the Z-axis, and here will be 0. We know that, okay? And then the rest is because the rotation is theta I. So we know that this is cosine I and cosine I, cosine theta I, cosine theta I. And here will be sine theta I negative, and here will be sine theta I. We know this from the rotation matrix that we discussed last week. Okay, so that's already done. Okay, now the next transformation. So that's from here, we move to there, and then we rotate. From here, we move to there, and then this is axis theta xi. We rotate, and then now xi becomes here in this direction. Okay, because we rotate already about theta I. So we move this origin towards there. Basically, that's what's happened. And then your xi was here, and your xi is rotated about theta I. Now your xi is there. I mean, your xi minus 1, your xi minus 1 is there. Okay, so the entire origin here moves here, and then the xi rotates there. So now this is the orientation of your frames now. So what's the next transformation? So the next transformation is that you move along x by A. So this is your x now. You move along x by A. So this origin, you move there. You push there. Okay? So once you move this origin to there, now they're coincident. This is your xi, but then your zi is still in that direction, and then your z is still in that direction because this is parallel, we didn't rotate yet, and then your y is somewhere there. Your y is somewhere there. Okay, so now as you move there, so that's the third transformation, move along xi by ai. So here there's no rotation because this is identity matrix, and you move along xi by ai, and the rest there's no movement along y and z. So this is 0, 0. Okay, so now what's the fourth transformation? The fourth is rotating about xi. Okay, rotating about xi by alpha. So rotate by xi by alpha. So now from This was your xi, your zi minus 1, rotate about xi. Now, when you rotate about xi by alpha, your zi minus 1 becomes coincident with your zi. Okay? So what happens here after all the transformation? What will happen is that the axis of your I minus 1, okay, raise a hand. Okay, and Pupelwa, you raise a hand?
Hi, sir.
Yes.
So all this transformation matrix is the one that you talked about earlier, the homogeneous transformation matrix one.
Mm-hmm.
That's why we end up having 4x4 instead of the normal rotation matrix.
Yes, we have a 4x4 matrix where in that 4x4, okay, let me, this one, it's a 4x4 matrix. Now you have a rotation part and the position part. Okay?
Yes.
Okay.
Thank you.
Now, in this case here, this is the rotation and the position. Rotation and the position. This is the rotation. Okay, let me draw. Okay, so that's the rotation. Yeah, and this is the position. Okay, and the same thing, this is the rotation, and this is the position vector. That's rotation matrix. This is rotation matrix, position vector, rotation matrix. Do you see my draw? Do you see my annotation? Okay, you see.
Yes, we see it.
Yeah. So now, just like what we said. Okay. So there is, in this case, you translate along D, along X. You translate along Z-axis by D. Yeah. So this is Z-axis by DI. Nothing about X and Y. Yeah. And also no rotation because you only translate. Yeah. And so after you translate, okay, I hope this one. The annotation will go down. Okay. Let me clear everything. Okay, I want to see this one as well, the drawing and the matrix. Okay, so let's do it one more time. So this is your rotation and this is your position. This is your rotation and your position, your rotation and your position, your rotation and your position. Okay, so you translate along z-axis by d. Okay, so you translate along x-axis by d. Okay, from here you translate to there. Yeah, okay, you move the origin of this frame to that frame. So now you move only along z-axis, nothing in the x and y, and also you don't rotate. Okay. So our objective again is to make this frame coincident to that frame. That means the X and the Y and the Z in this frame will become coincident with the X, Y, and Z in this frame. Okay? So that's how we know how the position and the rotation are being transformed. Okay, so that's the first transformation. The next transformation, we rotate only, we don't move. So in this case, we don't move. This frame here, okay, the frame remains in the same origin, but this is your x, I minus 1. We're going to move it towards in that direction, okay, in order to make it parallel to the xi. I mean, coincident to the xi, okay? So we rotate about, because this is Z axis, we rotate about Z, and we know how the Z axis rotation is, yeah? This is 1, and the rest is 0, 0, and here is cosine, cosine, and minus sine, right? That one we know, okay? So now, after these two transformation, translation, purely translation, and purely rotation, your frame now jumps from here to there, and then rotates from here to there. Okay, so now we are almost there. Okay, so now we need to jump from we need to jump this reference origin of this reference frame to there. So again, we need to move along the x-axis, along the x-axis only. So if along the x-axis, so now you have your AI, your A move along the x-axis, nothing about y and z. So that's 0, 0. And then nothing in terms of rotation. So that this one is identity. Okay. Okay, now once you have your coincident here, your origin is already here, but your z-axis is still there. Okay, that is your z I minus 1. Okay, so your zi minus 1 needs to be coincident with your zi, where your zi is here. And so you need to rotate about xi. So now, this is the last transformation. Nothing in terms of moving the position. Now you rotate about xi. So xi because 1, and the rest will be 0, 0, and this one 0, 0. And then cosine. Here, cosine, cosine, alpha, because alpha is a rotation, and then sine, sine, and this is negative, and that's negative. Okay? So there are 4 transformations. So after these 4 transformations, your reference frame I minus 1 becomes now coincident with frame I. Okay? So that's why we identify those, with those 4 transformations are made possible by the 4 DH parameters. Okay? The DH parameters of theta I, alpha I, and DI and AI made us have that transformation moving from frame I minus 1 to frame I, so that frame I minus 1 becomes coincident now with frame I. Okay? So 4 transformations. So we need now to identify those 4 parameters so that we will know what happens exactly between these 2 reference frames. What we need to do in order to transform from one frame to the other in terms of position and orientation. Okay? Any other questions? Okay, let's continue. So now, okay, we can discuss another meeting to have this one clear to everyone. Okay? Okay. So now, when we go about examples in the next meeting, it will be much clearer to you. So after all these transformations, if we just simplify all this calculation, then we will come out with something like this. Yeah. So we don't need to memorize this. Okay. It will be given to you, but this is just the relationship of all these transformations, 4 transformations. Okay. By translation, rotation, translation, rotation, you will have this transformation matrix that defines the relationship between 2 frames. Any 2 frames, any frame I minus 1 to frame I, this is the relationship given the 4 DH parameters. So now the problem now is that how do we follow the DH parameters? So we follow it according to this, okay? According to what we know about the convention. So again, any given axis, if this is joint I plus 1 axis, this will be rotating about ZI. This joint I plus 1 will be rotating about ZI axis. Okay? If it's joint I, it will rotate about ZI axis. Okay? From that convention, we will determine XI, because XI is perpendicular to both axes. That's another convention. And YI will complete the frame, the reference frame I. Okay. With that, we will know already where is the X, Y, and Z reference frame. And then we continue with all the rest of the axes. Okay. So now that's how we determine X, Y, and Z direction. And then after knowing the X, Y, Z direction, we need to know what are the 4 DH parameters. And then once we know the 4 DH parameters, we'll be able to know the relationship between those 2 frames by this transformation matrix. Okay, where this is the rotation. Again, the rotation, I will draw the rotation. This will become the rotation, the relationship of rotation between 2 reference frames, and then the relationship of the position between 2 reference frames. Okay? Okay. So for example, if we have, we will uh, we will only finish the time. Okay, if we finish the time in this one, then we will stop. Okay, so let's just look at this simple 3 degrees of freedom robot. We have computed this before without any reference frame assignments. Yeah, but now we will we will do it with a reference frame assignment. Okay, so now because this joint, this link rotates about this joint. So if this is let's say, for example, if this is joint I or joint 1, yeah, it will rotate about Z0. Okay, so let's just make maybe let's just make Z like that, and Z in that direction, parallel, and Z in that direction. Okay, so in that case here we have, okay, so this is joint 1. Okay, we say, we'll just label it, that is joint 1. Okay, because that is joint 1, it rotates, this is theta 1. Yeah, so now we have, this is theta 1 as is stated there, that's theta 1. Okay, and so joint 1 rotates about Z0. Okay, okay, now we know that. Yeah, so next, so if this is joint 2, so we'll do, this is joint 2. Okay, joint 2 rotates about, so now this one will be Z1. Okay, and in this case here, this is joint 3. Okay, and so this one will be Z3. Okay, so now we identify the directions of the Z axis, Z0, Z1, and Z2. Okay, we need to know where is the Z, where is the X and the Y. Yeah, so normally the base frame is arbitrary. Okay, that one was not clear in the previous slides. So the base frame, whereas in this case the world frame, Z0, X0, and Y0 is arbitrary. We assign it ourselves. Okay, I mean anybody, you can assign where is your X and Y with respect to the world. So in this case, we make this one X0 and we make this one Y0. So this is X0 and Y0, we assign it. Yeah. So now, okay, these are X0, Y0, and Z0. That's our base frame. Okay, so now the next one is that where